In this video, we'll be showing how to prepare a bidirectional direct simple shear cohesive sample. The first operation is going to be centering the shear box. In order to do that, you need to place a base with shearings into a base and make sure it's aligned perfectly. Then we'll be able to put an actual sample in the machine without performing a centering operation. As you can see, we place a mold with the shearings and secure it with clamps. Make sure it sits nice and tight, and go like one screw at a time. Make sure they all apply even pressure to the sample. In order to position your shear box, use your jog option on all the three axes you have. Start with the vertical axis, slowly lower it down. Make sure to stop it before it touches the edge of the shearing. This way you'll be able to see the gap on the X and Y axis between the shearing and the top cap. Then go to a jog on X and Y and adjust them in steps one by one until you see your top cap perfectly aligned with the top edge of your shearings. To remove your base and the rings and get ready for preparing your sample. Same procedure as you are putting it in, just in reverse order. Now, at this point, you don't move your shear box, just keep this position. The next essential step is to prepare a sample. Sample preparation starts from putting an O-ring on your membrane stretcher, and you'll use it later to put it on your bottom cap on a pedestal of the sample. After O-ring is positioned, you need to stretch the membrane over a membrane stretcher. It's a little tricky and you need to practice a couple times if you've never done it before, but the general idea is to try to evenly stretch it around the membrane stretcher and hold it on one side and just do the same operation with your other hand. So your goal is to put a membrane without any wrinkles and folds here, because afterwards you'll be applying vacuum. You'll use vacuum to expand your membrane even more to create enough gap between your sample. Carefully put your sample on a pedestal, turn on the vacuum and lower your membrane stretcher with a membrane over the sample. Unfold the bottom of the membrane on a pedestal. This will release the vacuum, and then unfold the top of membrane in order to free up the membrane stretcher. Remove the membrane stretcher and shut down the vacuum. Now the O-ring that you put previously has to go on one of the grooves on the pedestal in order to secure the membrane in place. Once O-ring sits tight, you can put a stack of shearings over your sample. It is easier to do if you pull your membrane a little bit upwards and then slide the stash of O-rings over it. Once sample is ready, you have to place it into a shear box. Start with putting the top O-ring over a membrane stretcher, so you can place it on a top cap. You have to try to push it as high as possible in order to give yourself as much room as possible for the membrane later. There are two clamps provided with your machine. They're different. Front and back clamp are different. Rear clamp has more like of a straight edge to it, and the front clamp has a little bit of a rounding, as you can see from here. So the one with the edge goes to the back of the shear bass. The one with a more of a grinded angle goes to the front. Bring your specimen in, position it all the way back, put the front clamp in, and start securing with the side screws and the top screws for the clamp. The clamp gets positioned with positioning pins. Secure it with the screws. Evenly tighten all the screws. Now you can lower your vertical axis, not all the way in, just slightly, so you have about an inch gap in between top cap and top of your shearings. Stretch the membrane over a top cap so it can get some good guidance for future lowering. If your membrane is too long, you can fold it over. At this point you have to remove the shear pins, because if you lower a vertical axis even more, you wouldn't be able to remove the shear pins, so you have to do it right now. Continue lowering the vertical axis. Again, not all the way down. Leave some gap in between shearings and the top cap. Fold your membrane even more. Continue lowering the vertical axis until you have a very small gap between top cap and the shearings. Before lowering the vertical axis even more and applying the seating load to the sample, the sensors have to be teared. Tearing basically is zeroing the offset on the sensor reading, and you have to start with a load in your template in your software. Go to Calibrate Summary and View System. These two windows will be needed in order to perform this operation. As you can see, we start from copying offsets in a system monitor window from every load cell axis and applying it into corresponding channel of the calibration summary. After these are applied, you have to hit Apply and Upload. Apply sets your new offset in the software. Upload feeds this new offset to the machine itself, so they all can be synchronized. Doing a displacement zeroing is not necessary, but if you want to be consistent, you can do it as well. We will show how to do it here. So you have to do all the displacement channels. The only one you are not doing yet is vertical displacement, because your vertical axis is not positioned all the way in. In order to do that, you go to vertical control window to control vertical load and apply a small seating load of 10 Newton to the vertical axis. Make sure your machine is not in a jog mode, otherwise it will not respond to your commands from the software. Hit go, and the machine will slowly go down, lowering your top cap until it reads 10 Newton on a vertical axis. This will not damage your sample, just ensure a proper contact between top cap and the sample. Once sitting load is in, you can position your O-ring on the top cap. It again has to sit in a groove on the cap, and if you have a folded your membrane, make sure it's not sitting on a fold, so it should sit on a single layer of the membrane. Work your way out in order to pull the membrane from under the O-ring. Once this is complete, the system is ready for future testing. Once O-ring is positioned and you have 10 Newton on your sample, type the offset for your vertical displacement transducer, hit apply upload, and OK to save it. Stop vertical control, and at this point you can start your test. If you plan to fill a shear bass with water, you have to put a shear bass cover. It is a simple operation, just slide the cover on screws sticking out from a shear bass and secure it with 9 nuts. The only thing to note here is that nuts have to be put in a certain order. Start with the corners first and go like a star pattern in order to tighten them. So at first just put them loose. Once you place all the nuts, you have to go and tighten all of them one by one. This will ensure a proper seal between the door and the edge of a shear bass. Once all the screws are positioned and tightened, sample is ready for a test. At this point, you can use your software to start a test. After test is complete, you only need to dismantle a sample. Once the test is complete, you have to pull out the sample from a machine. Start by draining the water from the shear bass if you had it there. Then you'll be able to remove the shear box cover. Again, remove the 9 nuts holding it in place and pull the cover off. Loosen the screws holding the sample in place and remove the screws holding the front clamp. Now you can start jogging the vertical axis up, and while it's slowly jogging up, remove the top O-ring from the groove in order to release the tension from the membrane. Once this is out, continue jogging your vertical axis up until the top cap is free. You can increase the speed and jog it up quickly until it hits the upper limit. There are 2 screws on the base of a sample, which can be used as handles to lever the sample out of a shear box.